Alright, welcome back with a different problem. So the advice is that you have watched the first problem. Now we're on the second one. We won't really touch the basics, so we just go straight to solving the problem now. You can see from this question statement, the maximum shear force of 5 kN is given. The blades are, which is this. These are the blades, these yellow ones. So they are attached to these channels. So here are the channels. They are attached via the bolt. So this is the bolt that joins these two components. Right. They have given us the pitch of 100 millimeter interval. We'll see that at the later stage. The shear stress in the bolts may not exceed 45. We'll see that at the later stage as well. Right, the first question now is to calculate the second moment area that cuts through the center of the channels. So you can see here is the channel. So the center of the channel, it will be the center of this channel, this side, it will be there. So if you check this XX line, is cutting this thing in the middle. So it's cutting through the center of this channel. Now, when they say through the center of the channels, they were just giving you the direction that they are not talking about the second moment of inertia about the YY. So as you can see, this YY, this line here, it doesn't cut either of these channels, doesn't cut one of these channels. So the one that cuts the channels at the center is this horizontal one, so which is IXX. Therefore, we have to calculate IXX using the parallel axis theorem. So before we go there, we're going to calculate the I total of this built-up beam in this way. We're going to assume that this thing initially, this profile, initially it was a box. That box, it something like this. So we're going to assume that this thing initially it was a box like this, which is this one, which is this. Okay, before we go far, let's find the dimension of this. So from here to there, it's 100. From here to there, it's 100. It's this dimension here. Then the height of this box is going to be the distance from here to there. So this distance, we are going to say this distance here, which is 12, plus this distance here, which is 10, plus this distance here, which is 80, plus 10, plus 12. So that will give us the total distance. So the total height of this will be equal to 12 plus 10 plus 80 plus 10 plus 12. So which is 124. So that will be the height of this box. Now after that, we move. Okay, as I've said that, now we're going to assume that we're going to remove this. So this part here, we're going to remove this. So this orange line that you see there, they represent this part. They represent this part. So we're going to remove this, which is this. We remove this. So these things that we remove is this one. But now you can see we've got two of them. So we've got two of them. Let me just multiply by 2 here. Multiply by 2. Got two of them. Multiply by 2. So it's these two boxes here. So now let's find the dimension of this. You can see from here up to there is 25. And then this distance here is the thickness of this channel, which is 10. So it's this one. So this channel, we can say it's constant. The thickness is constant. So from here to there is 10. So if from here to there is 25, then we're going to minus this 10. 25 minus this 10, we're going to remain with 15. So from here to there is going to be 15. Then this one here is 10. Then 15 plus 10 equals to 25. Or we can use the other way. Someone maybe can say that let this distance, we don't know it, let's call it x. Let's call this distance x. Then we'll say x plus x plus 10 plus, so remember 10 is this one. But that will be longer. I think the first one that we did is the best one. Okay, it's fine. Plus this 10 here, plus from here to there. So if from here to there is 25, 25, then total length is 100. Then 100 minus 25 minus 25, you will remain with this distance here in between, which is going to give you 50. Plus 10 plus x. This should give you 100. Then from there you will have 2x, which equals to 100 minus 70, so which is 30. Then 2x equals to 30, then x should be equals to 30 divided by 2, which is 15. Right, so the dimension of this one, this side would be 15, and then this side, which is So this side, which is from here to there, is 80. So this is going to be 80. Now, after subtracting these two, we subtracted this one as well. We subtract this, something like this. So which is this part? So let's find the dimension of this. So from here, from the bottom here to there, is going to be this distance 80 plus this 2, which is 10, 10. So 80 plus 10 plus 10 is going to be 100. And this side, which is this side here, which is from here to there, it's 50. 100, so this 100 minus 25 minus 25. Then you'll get 50 there. Right. So from here, we can use parallel axis theorem to calculate the first question. Let me also remove this. So as you can see here, this this line which is XX, you will see that the center of this box, of this black one, is going to be somewhere here. So which is going to be in line with this XX line. Then again, you will see that the center of this red box is also somewhere there, which is in line with this XX line. So again, the center of this box is going to be somewhere there, which is in line with this XX line. So what I'm trying to show you here is that the center of all these boxes, they are on the same level. Therefore, if we have the center of the composite on the same level with these individual profiles, then it means that we are not going to have H. So I'm talking about the parallel axis theorem. So I XX equals to I plus AH squared plus I plus AH squared plus I plus AH squared. So we know that this one represents this black box. This one represents this red box. This one represents that blue one. So as the center of these boxes, all of them, they are on the same level with this XX line, then the H is going to be 0 in that case. Now we know that to calculate I for rectangle, we use BD cubed over 12. As I've said, I won't really go to basic. I equals to BD cubed over 12. I said that B is going to be the side. Let me just write it here. I equals to BD cubed over 12. So this one will be parallel. This one perpendicular. Perpendicular to this axis that will be written here. Right. So here we don't have to worry. This axis here for box number 1, the black one, this line here that crosses here, we're going to call it XX for box number 1. Remember we said that normally the axis parallel to the longest dimension is YY. Remember from here to there is 124. So 124 is long compared to 100. Therefore, perpendicular to the longest dimension is XX. The same here, we have two sides, we have 15, this side we have 80. So perpendicular to the longest dimension is XX. So this will be the x-axis of box number 2. Then here we're going to have the same thing, the x-axis of box number 3. So this is 100, perpendicular to the longest dimension is XX. Right, meaning that here, since we're using parallel axis, here is x-axis of everything, which is this one. So you go to number 1, you check the axis parallel to this x-axis of the composite. So you'll find that this x-axis it's parallel to that x-axis of the composite. So the same thing, all these boxes, this line here is parallel to this. This line, which is x-axis, parallel to this orange line there. So we're going to have x-axis for both. So now number 1, box number 1, this black one. So we're looking for IXX. So the dimension parallel to this XX, we're going to take it as B. So which is 100. 100 is parallel to XX. So it's going to be B. So we're going to say 100 multiplied by the other side perpendicular to XX is the one that we're going to raise to the power 3. So which is that 124. So we're done with this part. Remember, this one is 0. So the area is there, but anything multiplied by 0 will be 0. So this part I'm going to ignore this one because of this 0. So we go to number 2, which is this one here. Sorry, it should be minus here. Where is this plus coming from now? We subtract. Right. For the second rectangle, you will have parallel to this x here. It's going to be this side of 15. Then we'll have 15 0.015 multiply by the other side is 80, 0.08 to the power 3 over 12. And remember here we have two of them, so you multiply by 2. Remember this one and this one. Then from there you go to this one here. So the parallel side to x-x, to this x-x, which is this, the parallel side is going to be 50. So you will have 0.05 multiplied by 0.1 to the power 3 over 12. Then you will get 10.4418 times 10 to the power minus 6 m to the power 4. So that is the first question. That is the first question. They've asked us to calculate the second moment of area that cuts through the center of the channel. So this is 7.1. Right, we can do this in different ways. I know some of you do have the memo. So they've done it differently in your memo. But I can just touch it so that you don't get stuck. This question paper is April 1 for the year 2024. So if you go to their memo there, they calculated I differently. I'm not going to do it. I don't want this video to take long. But they took this route of finding the I for this. Yeah, I for this box, but we've got two of them. So remember, let's say consider maybe, let me call them the blades. So I will be equals to this plus this. So I will be BD cubed. The side parallel to this is going to be, remember your parallel axis for this box will cross like this. Then the side parallel to that is going to be 100, 0.1 multiplied by perpendicular. The side perpendicular is going to be 12, 0.012. As this side here, remember this side is 12. Plus the area, which is 12, 0.012 multiplied by 100. H, what is H? The H is going to be the distance from the centroid of the composite. Centroid of this whole thing is here. So H is going to be the distance from here to the center of this box, or to this center here. So now remember, the distance from maybe here to this center is going to be 6. It's going to be 12 divided by 2. So if you want the distance from here to there, then we're going to say from here to there plus this distance here. Remember, from here to there is going to be 40. 80 divided by 2. That is from here to there. 40 plus this one here, which is 10, which is 50 now. 50 plus this distance here, which is 6. Then we're going to have 56. So you will have 56 here, 0.056 squared. So that will be the eye of one plate. But remember, we have two plates, and at the end we have to multiply it by 2. So this one is just going to be an eye of one plate. Right. From there, we have to find the eye of the channel. So they will approach this channel like this. They will say before this channel comes like this. Sorry, it was initially this, a box like this minus this part. So if you take a box like this, then you subtract this part, which is going to be this, you'll get this. This part here from here to there is going to be this one. From here up to there. So we said, as you can see, from here to there is 25. So it's 25. And from here to there, we said is 15. This distance there. So which is this one here, which is represented by this 15. And then the vertical height of this box from here going up there, from here to there, which is from here to there, is going to be 100. Remember, it's going to be 80 plus 80 plus 10 plus 10, which is 100. Then from there, this, the height of this box, which is from here to there, this one is 80. So which is this one here, 80. So now to find this, we're going to approach it in this way. So we'll find the eye of this big box minus the eye of this small box. Then you'll get eye for one channel. You'll get eye of this channel there. So now you will see this XX. You will see the center of this channel, which is along here, is on the same line or on the same level of this XX of the composite. So this is the XX of this thing combined. But at the same time, the center of this channel is going to be here. And the center of this box, this part that we're going to remove, the center of it is as well going to be there. So they're going to be on the same level. So once we have these things on the same level, then the AH part will disappear. So I will be this plus AH squared minus I plus AH squared. Remember, this part is going to be this one here, then this one is going to be this one. In that way, you will be trying to find I of this channel, which is this channel here. Now, as I've said, that the center of this lies on the same level as this XX, on the same level as the center of the whole thing, then H is going to be 0. H is going to be 0. Now you will only remain with the I's. Then the I for this big box, remember the dimensions here, you have, what are the dimensions? I think it's 125, yes. So you will have parallel one is 25, perpendicular one is 100, 0.1 cubed over 12 minus, here now parallel one is going to be 15, perpendicular is going to be 80. Then you should get 1.443 times 10 to the power minus 6. So that will be I for the channel alone. So this 1.4 is for one channel. So one channel is going to have the I of 1.4, then we've got two of them. That's why we have to multiply by 2. And then one plate as well is going to have this I of 3.7. Then because we've got two plates, now we have to multiply by 2. Then at the end of the day, you will have I total, which is going to be 2 times 3.778. Then you should get the same answer. So that's how you calculate I. Right, 7.2, we have to find the suitable diameter, meaning the diameter of whether it can be the rivet or the nail. So if you're going to use the rivet, you have to know the diameter of this jointing, of this joint. Now to find this diameter, remember we have to find the shear flow. Remember I said that the strength of the bolts that you need to use, it depends on the magnitude of the force that will be created as this beam bends, which is that shear flow there. So now let's calculate the shear flow. Remember shear flow Q equals to V Q over I. Now maybe let's find the Q. Q equals to A multiplied by Y bar. So now our interest, or the part where these two joints, is going to be here. along this. This is where these bolts are going to experience that sliding or that shearing. So this is where these two components meet. This is where the blade and the channel meet. So now we have to find the shear flow on this point. We have to know the magnitude of the force that will be created here. So now, as you know, that Q is going to be the area above or below the line of interest. So our line of interest is this one, and the area above it means it's going to be this area, which is going to be the area of the rectangle. So the Q, we have to use the area of the rectangle. So which is 100 multiplied by 12. What about Y? Y is going to be the distance from the neutral axis to the center of that yellow area. So the center of the composite is here. Then it will be the distance from the center of this yellow area to the center of this. So remember, from here to there is how much? It's going to be 50. Remember, from here to there is 40, 80 divided by 2, plus this one here, which is 10, plus this distance here, which is 6. Oh, it's 56. We've already discussed this. So it's going to be 56. So our Y bar from the neutral axis to the center of the area in consideration is going to be 56. Then you'll get 0.00000672. That will be Q. The Q of this one. Remember, we've got two of them. So this one is area moment. This one is the shear flow. So we're trying to find the shear flow. We have this one here is given, I think, if I still remember very well, the shear force. The shear force is given as 5. So shear force is given as 5. So it's this one, we don't have to worry. Shear force is 5. We calculated Q, we calculated I. Then we just have to substitute. So from this equation here, V is 5,000. Q is 0.00000672. All divided by I, which is 10.442. So Q will give you 32,000. kilonewton per meter. So that is the shear flow. Now remember to have the state of equilibrium between the surfaces of this beam. The shear flow must be balanced by the force by the rivets. The rivets has to resist. So as I've illustrated in the first video. So F bolt equals to Q. So as I've said that as the beam bends like this, it's going to shrink maybe like this. So to avoid this shrinking or sliding, we insert bolt in between so that it can prevent this sliding. So to prevent that sliding, it will only happen only if when the beam starts to bend. So there will be a force created in this direction. Then if this is our bolt, the bolt must push in opposite direction with the same magnitude. So that's what we're trying to see here. Now, F bolt, the resisting force by a single bolt, or the resisting force by all bolts. Let me use all bolts. Resisting force of the bolts for 1 meter length. We've discussed the formula is going to be pi e squared over 4 multiplied by shear stress multiplied by n, which is the number of bolts, multiplied by c. C is 1 for single shear, and then c is 2 for double shear. And then q is calculated. Q is calculated is that 32.17774. So actually we're looking for this. This thing represents the diameter of one bolt. This D. We're looking for this. So at the moment we have the shear force of the bolt. When you check from the sketch, you will see that we're going to have single shear. And then we don't have N. We don't have N. So before we can find the D, it means that we have to find the N. So from the first video, I've said that I've illustrated a scenario of double shear. So this one, if you are the bolt is only used to join two blades together, then we're going to have the single shear. So this bolt will experience a force in that direction and then in that direction at this point or at this point only once in one area there. So that's why we're going to have a single shear, meaning that if the force is big enough, that force in this bolt, if it's big enough, then this nail or whatever is going to fail due to shear. So when it fails, it's going to slide like this. So that sliding is the shear. It's going to shear at this point. So we're going to have a single shear there. Right, C is going to be 1. So I was just here on this C. It's going to be 1 single shear. So now let's find the number of bolts. So let's find the number of bolts. So remember they give us pitch. So since they gave us pitch, we know that pitch equals to unit length which is going to be 1 meter. Remember here we have per meter for 1 meter length. So this is the shear flow for 1 meter length. So multiply by the number of rows. All over n. So this is total number of bolts per meter length. So now we're looking for this guy, for this n here. So since this is the shear flow per meter length, this n as well, this n here will have to be the number of bolts as well per meter length. So which is this? Okay, to have the n per meter length, then we have to use 1. The unit length must be 1 here. Then we'll have the number of bolts for 1 meter length. So now we just have to make n the subject of the formula, then n will be equal to that unit length, number of rows, multiplied by pitch, which is 100. It's given. So the number of rows they don't have to give you. You can just check the sketch. So the interval is this one here. It's 100. That is the pitch or the spacing. So the number of rows, this thing will be like this. So you'll have bolts here. So you're going to have this row here and then the row of bolts here. So you'll have 2 rows. You will have 2 rows. So they don't have to give you, especially if they give you the sketch, then just check the sketch. Then you can see the number of rows that you will have there. So if you see 3 bolts from the front view like this, if you had the third bolt here, another one here, another one, then it means you will have 3 rows like this. In this case, we're going to have 2 rows. So we just have to go now. We just have to go now and substitute. So unit length is 1 meter multiplied by number of rows is 2. Pitch is given as 100 divided by, we change 100 to meter, we divide by 1000, then we'll get 0.1. And then the number of bolts per meter length is going to be 20. Then the last part, we just have to come here and replace this n by 20. Then you'll see the only remaining thing will be d. Then maybe let's make the d the subject of the formula from this. Yeah, making d the subject of the formula from this. You will have d equals to the square root of 4 multiplied by 32.1 divided by, we're going to divide by pi, and divide by this shear stress is given, it's 45. And divide by, what are we making? Yeah, divide by c, or n, the number of bolts. So it's 20 multiplied by c, single shear, 1. Then your final answer will be 0.006747 meter. That is the diameter of the bolt. Changes to millimeters, 6.74. But when you go to the shop, you'll find that you don't have this size in the shop. In the shop, maybe they will make diameter of 6 millimeter, 5 millimeter, blah blah blah. So you won't have exactly this size. And that's why you must go and take a slightly bigger size. So you round this thing to 7.4 millimeter. So this one, remember, is just the minimum diameter. This one is just the minimum diameter. It means that in order for the bolt not to fail, or the bolts not to fail, at least the bolts must have the diameter of this much, 6.74, not less than this. So remember, the bigger the diameter, the stronger the fastener it becomes. So from 6.74 to 7, it will have a stronger bolt, stronger fastener. So which is good. So we want more resistance. So as long as it's gonna provide more resistance compared to the shear flow, then it's good. Right, yeah, that's the end of our problem. Thank you.